So again, if you didn't get a chance at the end of last class, or if you weren't here last week and didn't get a chance, that's on Edmodo. No worries if this is your first webinar. I know some people have an issue meeting on Wednesdays, and some people might have just been busy just last Wednesday. But, and this is what's so great about Edmodo, you can see here that if you click, I posted this link, and I'll post it as a refresher again. Every week, I will be adding videos to this playlist, so clicking that one link will always bring you to this webinars playlist, and this playlist will grow as the Mondays and Wednesdays add up. So if you missed one, you can check it out online. And I do apologize. This one, it looks like some of my recording got lost, but GoToWebinar did not have it. Luckily, we went over the same material as the 7 p.m. So if you missed on Wednesday, I would really recommend looking at the 7 p.m. Even though I know you're in the 8 p.m. webinar, we went over the same material. Okay. Please type out a question if you have a question. Again, maybe if you're just getting here, I cannot tell if your hand is actually raised or not. So if you have a question, don't try raising your hand. I don't want to take the time to restart the webinar right now because we only have an hour and I want to jump into the material. So we're going to go based off of the questions today. And again, you can access the questions in the GoToWebinar control panel. There should be a little thing that says type a question, and only I can see those questions. So that's going to be the way we communicate today. There's also chat if you can't figure out how to operate the questions area. Okay. So we're going to do a quick review. I think that we did in class, we got to talk a little bit about engineering your aptitudes. And Jasmine, I remember you were here last week. Is that correct? We got to about here. I'm going to unmute you if that's okay, Jasmine. And you can keep yourself muted if you don't want to speak up. Hey, Jasmine.
Hey.
Do you remember, we did go through these aptitudes, is that correct?
Uh-huh.
Great, wonderful. Okay, and so we're going to do a quick review of this. So to be a good engineer, there's some things that we look at here. A background in math and science, because engineering is the application of math and science. Are you a problem solver? Are you a problem solver who's going to persevere? Are you persistent? Are you going to keep working on that problem? Even if you fail 99 times, you're going to go for that 100th try. Are you a team player, and can you communicate? These are two very important skills, and we're going to take a look at that a little bit later. Are you able to communicate to your team members what you need? Maybe you are the person that takes apart the machine and puts it back together, and someone else on your team is the programmer, and someone else on your team deals with all the money. Well, you all need to communicate to each other so that everyone has a good idea of what each member is doing so that you guys can help each other out. Webster's dictionary defines engineering as the practical application of science and math. It's using that application in the design and construction of machines, vehicles, structures, roads, and systems. And again, that's where I say the application of math and science for the betterment of society. Half the jobs created today are the result of technology. However, many jobs are being lost to technology. So this is kind of like a riddle, right? These sentences seem to be it doesn't seem to make sense. Like how are we losing jobs to technology if half our new jobs are that we're creating are because of technology? Well, let's take a look at this picture. So here we see these different kinds of robotic arms. So these things have been are really, really neat. I don't know if you've ever seen a robotic arm in action, and they're really precise and they're really strong. And people have programmed them to do really specific tasks. And so a whole suite of robotic arms can together work on this kind of rotating platform or moving platform and put together pieces of machinery. Um, and so this, because these bigger projects are now automated, meaning that a machine or a group of machines is doing them instead of humans doing them, a lot of jobs are going away. Or maybe you have think about when you call in to figure out why your phone isn't working. And I don't know if you've ever had to do this, but maybe you've heard of other people doing this. Instead of there being a person, like an operator, that answers the phone, a lot of times it's automated. It's an automated message. You're able to call and see how much money is in your bank account without ever talking to a person. All of these, machines taking jobs that big groups of people used to have to do. And you can kind of see here, right here, there's a little person right there. That person is watching the robotic arms, making sure that they are functioning properly. And so that's where it's talking about here that half of the jobs created today are the result of technology, not is, are the result of technology. So before, maybe before the invention of robotic arms, there wasn't this job where you had to have that technical knowledge of robotic arms, right? Robotic arms had to come first. So this is a new job. Someone that repairs iPhone screens when you break or when you drop your phone, your cell phone, and the screen cracks. The job where someone replaces that glass, which is actually an industry now, didn't exist until we had all these cell phones. So there are many jobs that are being created because of our use of technology. However, these jobs that require a lot of people are being replaced by technology. So if we take a look at this chart, I know this chart might be a little confusing. 0 means no job growth. And it's also looking at females and males, which is pretty cool for this all-girls class. Not good here. A lot of the medium skill jobs. I'm so sorry. I don't know why my mouse keeps doing that, my touchpad. A lot of these medium skill jobs, definitely in the office and production and operators like on the phone, what I just talked about, when you get an automated message instead of a real person, those jobs are being lost. Not as many jobs are being created there. Whereas some of these professional, technical occupations, where you have to have that technical knowledge, that engineering knowledge, well, we need a lot of engineers right now. That's a huge need. So those are you see a lot of growth in that area. The issue gets to be where there's a large population that has this medium skill level or the requirements to get a medium skill level job. Maybe their high school diploma or their college diploma, just the undergrad diploma, and it gets to be we're losing a lot of those jobs, but we still have these jobs that take so much training for. All right, we're going to move on from this. All right, does anyone have a question on this? You can type in a question. No? Okay, we're going to move on. We're going to take a look at the different fields of engineering. And the reason that we have this slide, no, you should not choose your career based on salary. I don't think we're trying to say that at all. But we do want you to think about what it, consider. A lot of people consider what it would be like to be a doctor or to be a lawyer or to be a dentist, fireman. What would it be like to be an engineer? And there are so many different fields of engineers, and you're doing so many different things. And definitely one of the benefits, one of the selling points, is that you're making a lot of money. So they took all of the colleges across the United States, and they looked at all of the majors across all the colleges. and they looked at right out of college, and that's this bottom bar here, the kind of purple one. This is how much they're making. And further into their career, when they've been doing their job for a long time. That's this upper blue bar. And $40,000 a year, that's the national average for an entire family in the United States as of 2012, 2013, around that. So a little over 40. So you can make a lot of money in engineering. Petroleum engineering. Does anyone have an idea of what petroleum engineering is? Gwen, it looks like you raised your hand for that. Gwen, no, you did not. Okay, I'm glad that I did not call. Okay. No, Gwen, I won't call on you, don't worry. Okay. Petroleum engineers work with fossil fuels. And they make a lot of money because, fossil fuels is a pretty big industry in America right now. And we're going to talk about what a chemical engineer does, what an electrical engineer does, what a computer engineer. We'll get to that. Someone has a question, though. How heavy are the robotic arms? Very, very heavy. And you can see these actually might be movable. But you can see they're all very specialized, too. Like this guy looks very different from this one. And that's because they're all doing very different things, and they're kind of set up in the machines. And the reason that I point that out, I can't actually give you a number. I could look it up for you and post it on Edmodo later. But one of my students, his dad works for Hyundai, and he makes robotic arms, and they made their first movable robotic arms. And it can save a manufacturing plant a lot of money. That way you can use the same robotic arm for different things without having to go through a huge hassle. These guys are very, very heavy. Okay, so I actually use raising your hand a lot, so I'm going to keep using it because some people are able to, and I'm sorry if you're not. But raise your hand if you have you studied the scientific method before? Okay, I'm seeing a few hands go up. Awesome. Great. So we're going to take a look at the scientific method. And what you're doing here, you start as a scientist with observation. You take a look at a set or a circumstance, and you try to figure out what's going on. You make a hypothesis. You make a statement or a claim about something that you observed. Why when I drop this soccer ball or let this soccer ball roll off my hand, why did it fall to the ground, right? You're making this claim on why you think that happens. Well, I think there's something called gravity. And you experiment. The scientists set up really, really regimented experiments where they gather data and they try to do it in very analytical ways of looking at that data, and they analyze the data to see, is their claim, is their hypothesis true? And then they draw a conclusion from that. Yes, their hypothesis is true. No, it is not. Oh, goodness gracious. Got a whole bunch of things popping up. Oh. Don't want that coming up during webinars. There we go. And so you analyze that data, analyze your experiments. Was my claim true? Was it not true? And you draw a conclusion. And then you publish that conclusion. You let all the other scientists in your field know, hey, I dropped a soccer ball, and I think that there's something called gravity. And here are the experiments I did. And I either agree with my original hypothesis or I don't. What do you guys think? And then people analyze. They take a look at the data. They take a look at the hypothesis and the experiments and the data, and they can either agree or disagree with that conclusion, and that's the peer review process. Engineering process uses that what the scientists have already discovered. We use the terms theory a lot, like the theory of evolution, or honestly, the theory of gravity. But there's a difference between a guess, an educated guess, and this, kind of this theory that all the scientific community agrees on, right? So they use these scientific theories, what we can think about as scientific laws and mathematical laws, and apply that knowledge to the engineering field, whatever specific engineering field they're working on. So engineers used information about energy conservation when they designed catapults and bows and arrows. And engineers used information about density and volume when they created the hot air balloon. Right? They're applying this scientific and mathematical knowledge in order to create these innovations. So the engineering method is a little bit different. You have research. I just want to make sure that I don't have any questions. Okay. Any questions? We're going to go through this method right here. Where we research, plan, prototype, and commercialize. And we're going to look at the car industry. So the first step is to research, where you look at the mathematical principles in the area that you're looking at, the scientific principles in the area that you're looking at, and you might also want to look at the market, what other people in your section of the economy or whatever kind of problem that you're working on, what other people are doing and what other people want. So let's say you're an engineer in the automotive industry and you want to figure out how to make a safer car. Well, during the research phase, you're going to ask a lot of questions. Questions about the mechanical parts of cars, questions about how the human body works, and how the human body responds to that kind of stress or car crash. And you're also going to look at what do people want? They want their car to be safe, but they also want their car to not cost extravagant amounts. They want it to be affordable and they want it to be comfortable at the same time. So actually a really good example of this is they used to think that it would be safer to put a seatbelt. You know how your seatbelt kind of makes this, I wish I could actually draw on this. It kind of goes across your lap and then goes across your chest. Well, for a while, they thought that it would be safer if it went across both sides of your chest, kind of like in a car seat or in a booster seat. Some booster seats have that. I think most of them just work with the regular single cross. Engineers learned that it's a really, really big increase in discomfort. It's really uncomfortable to wear that cross, the two seat belts pretty much. And it actually does not increase your safety a significant amount. So that's an example there. You've got to look at all these kind of factors. And then they make a plan. Let's say they want to, they're looking at increasing safety by looking at airbags. They're going to identify exactly what they want to do, and they're going to brainstorm in a big team. They'll get a team of engineers together, one that knows just everything there is to know about the human body. They work with test dummies all the time. You've seen those. And maybe they have someone that has built cars for years and years and years. Maybe someone that specifically just works on safety features of cars. Maybe someone that specifically is just a mechanical engineer and has a larger mechanical background. They get a whole mix of people together, and they work together to come up with brainstorms. And from their huge list of ideas that they kind of create together as a team, they select one and they build a model. And you can see here they used to have to draw these models out using a very systematic and mathematical approach to drawing these. But we're actually going to experiment with drawing in 3D. when we do 3D printing, and that's what they do as well. And they get a proof of concept. So they show, whoever is funding this venture, this is what we're gonna build. This is what we're gonna prototype, and this is why you should continue to fund us. This is why it's gonna work. And then they prototype it. They build an actual, sample car, quote unquote, that they're gonna run a bunch of tests on. They're maybe gonna let the user interact with it, but first they're gonna let that test dummy run through some simulations a lot, and they're gonna do that a lot. They're gonna have that prototype, run it through tests, tinker with that prototype, run it through tests over and over and over again until they're ready to send it out in production, to add it to their cars. So, oh, I'm so sorry you're having trouble with computers, Kate. I definitely empathize with that. We are going through the engineering method right now. You can watch the first half hour on YouTube in a little bit, and you're joining us. We just finished going through the different steps. We took a look at the scientific method, which you may have looked at, which is going through a hypothesis and testing that hypothesis. But the engineering method uses science and math principles to solve really specific kind of human problems. Now we're going to take a look at the types of engineering that there are out there. I think many people think of engineers and they think of people sitting at desks, maybe you think of someone working on a car covered in grease, kind of with a wrench in your hand. Maybe you think of someone with a hard hat on, with big blueprints in your hand, looking at a bridge, which sounds pretty cool. Maybe you think of someone driving a train engineer. Hey, you never know. Maybe you think of someone slaving away at a computer, kind of typing furiously. Well, there are a whole bunch of different ways to be an engineer, and really different kinds of engineers for everyone. We're going to take a look at a few of the options here. Chemical, chemical, civil, electrical. These are all working. Civil is going to be working with things like bridges and roads. Chemical and electrical, that's using that kind of specific scientific knowledge and applying it with engineering themes. So with chemical, that can look like anything from chemical for the dry cleaning industry, all to working with dog food companies, and also with much bigger industries where you're working with the chemicals there. Civil engineering, again, like roads and bridges. Electrical engineering, we need a lot of electrical engineers right now. Can anyone think about why we would need a lot of electrical engineers right now? What do people use a lot right now? Everyone's using it right now. I will absolutely let you. Okay. Smartphones and computers, Allie, absolutely. So there's this new field called mechatronics, where it's a combination of mechanical engineering, learning how all those parts and motors work, electrical engineering, learning how a circuit works and how electricity works, and programming, computer programming. And because we use technology, absolutely, Gwen and Ava, all three of you are hitting this right on the head. Technology, computers, smartphones. We need electrical engineers because the world is surrounded by circuits now. So every field, you know how we talked about that airbag. Could not think of that term for a second. I apologize. That airbag example from before. Well, you've got a lot of electrical devices that are in the front of your car. So you would need an electrical engineer on your team of engineers to make sure that there would be space and that it could fit well, and that that change in pressure isn't going to affect the anything else in the car. Engineering sciences, geotechnical, mechanical, these are all might be kind of engineering that you think of, a more traditional kind of engineering that you might think of. I want to talk about engineering management for a second because if you see yourself, wearing a suit to work every day, working in these teams, working with people, that's what engineering management is. How can you make a company run at high efficiency? How can you save a company money? That's what engineering management does. And here it talks about the different kinds of mechanical engineering. We're not going to go into this too much. I think that this is for another lesson where it kind of takes you through all the separate kinds of mechanical engineering. But you'll see aerospace, rockets and aviation, car industry, prosthetics, and we'll learn more about that as we continue. Okay. This is a little cartoon. Okay, and basically it's talking about, so a user approaches a group, and they actually would approach an analyst and say that they wanted a system built. And if you haven't done, let's say like a computer system, and they're making this analogy, or they're making this comparison, saying that instead of it being a computer program, let's pretend that they're trying to build a swing set. So the user goes to the analyst and tries to describe what they want, the swing set they want. And the analyst, after talking to the user, already has a much different idea of what the user wanted, right? This is like the game of telephone. So when they went ahead and talked to designers, the system was designed already looking different from how the analyst saw it. And then when the programmer actually has to go and cobble it together, it is not quite working as planned. What the user actually wanted, so there's a difference even there. I really like that distinction. I'm so sorry. What the user actually wanted was a real swing and not this rope swing. They just didn't know it yet. And how it ends up working, it's kind of a combination of all of the above. So ideally, when you're an engineer, you end up building what the user actually wanted, not this hobbled together rope swing. But what we're going to look at right now. Oh, let me jump back a few slides. Based on that cartoon, which of these skills was that group not doing well with? Which of those skills do you think they needed to improve? They were not demonstrating one of these. Team player, I heard from Grace. And I agree with, yeah, a couple of people are saying team player. A lot of people are saying communication. And I think it's really communication, because they were trying to be team players. They were trying to each do their part, but they weren't communicating what the goal was. And we're going to work with that at lab. Okay, great. A lot of people are responding. I just make my day when you respond to my questions. And I promise you, we'll get the microphone working for next time, so that I will call on the people that want to be called on. I don't want to call on anyone that's just, still trying to figure everything out. We have a quick question. Someone was asking about, let me finish this communication and then I'll talk a little bit about bioengineering in case you're interested in that. Someone had a question on that. So the reason that we went over that cartoon, and I'll let you take a look at it right now for one more second. Drink water. Take a look at it again if you didn't get a chance to fully read it while I was explaining it. You might be the most brilliant system analyst in the world. You might just be the top of your field intellectually. But if you can't communicate to your team, you're just not going to function well. That is one of the most desirable attributes that employers look for. Communication skills, verbal and written. Teamwork skills, interpersonal skills, relating well with others, working well and relating well with others. Can anyone think about some things that you can try to do to increase your communication skills? Some groups that you could talk about. Kate, I'm glad that you like the Goldberg Burger game. We're going to get to that in a second. I actually posted the links on Edmodo. Can anyone talk more to the user? Absolutely. But have a really open conversation with the user. I mean, what can you all do as middle schoolers? What are maybe things that you're doing right now? Let me give you an example. Think before you speak. Absolutely. Empathize. I was thinking about something like theater. Participating in theater improves your confidence. It improves your public speaking skills. It's a great way. Speech and debate. English class. Talk to each other more. I think that, Ali, you had a question mark there, but that's so true. If you are just texting your friends, uh, if you are kind of sitting in a room and everyone's looking at their phone, and I'll go ahead and raise my virtual hand with that. I have definitely been known to do that. You're not practicing having a conversation. Sometimes having a conversation is harder than just sending someone an emoticon. Public speaking, like a skit. Yeah, Ali, like doing a skit or doing improv, like a club. Yeah, and we are going to meet up and talk to each other. It's also important, they say that the best way to learn something is to teach it. So when I ask questions, if you're able to put things in your own words, it's going to solidify your understanding. Absolutely. Okay, great answers. We're going to shift gears here. These 3 games I just posted on Edmodo, and we're going to spend the last 10 or so minutes of class, probably a little bit less than 10 minutes of class. I'll get you guys started on these. But for right now, we're going to shift gears majorly and start talking about HTML. Oh, you're in Girl Scouts. That is awesome. I am a Girl Scout. I'm a lifetime Girl Scout. Gold Award and did the whole Daisy Troop thing. So I'm a big Girl Scout fan. We got some more Girl Scouts in here maybe. Okay. So we are shifting gears, and I know this is a big change, but we just had to get through that introduction, maybe understand a little bit better. And before we do that, I remember that someone had a question about biomechanical engineering. So before we shift gears, let's take a look at that. We don't actually have any examples here. So a biomechanical engineer would have a good idea of, or a biomedical engineer would have a good understanding of biology, hopefully human biology, but it could be, maybe in the veterinary field. So of biology, of the medical industry, and of engineering. So that's a really wide open field. It could be something like in biomechanical engineering, you're looking at prosthetic limbs. You're looking at the way a seatbelt works, because you have to have the knowledge base of how the human body works and how different mechanical systems work. A biomedical engineer is a hugely, rapidly evolving field. They're looking at being able to design medicine specifically for your own DNA. So think about cancer-fighting medicine that is made just for you. There's some really cool things with biomedical engineering that we're going to look at when we get into 3D printing. Oh my gosh, I see that some of you are in a Girl Scout troop together, and I have a lot of Girl Scouts. That just makes my day. Hopefully, Pearl, that answered your question. Cool. All right, let's take a look at HTML. HTML stands for Hypertext Markup Language. So we are not going to get to the Google site today, but hopefully we'll get to it at least by the end of class Wednesday. Give you some time to work on it over the weekend. Before we build this kind of drag and drop site, we want to take a look at on how any website is created, the language behind the website. Because we are engineers, we don't want to just be consumers of technology. We want to be creators, and we want to be able to understand what we're creating. So why are we building a Google site? We're building it to document our work. You want to be able to look back, at the end of the semester and think fondly back to these early days. We'll do things like take screenshots if we're doing something online, and you can post that to your site, where you can take actual pictures when you go to lab. And we'll talk about kind of like the rules and expectations when it comes to pictures in just a little bit. Okay, why are we doing Google Site? It's easy, it's free, there are a lot of templates, and it's customizable. Okay, some really, really important internet safety tips. I know that you have probably heard this. Hopefully Girl Scouts has gone over this, that's for sure. But we're going to go over it now, and the reason that we're doing this is because it is so important. These are just general tips and rules too. They apply to our Google site, but it's just good practice. Don't share information about your family, relatives, and friends. Don't share full name, address, phone number, location of your house to anyone on the internet. This is a good practice to stay safe because you just don't know who's going to be reading that information or accessing that information, even if you think that information is safe. Even if you think that this is just a little, profile that you're making just for you and your friends. No last names, no full name, definitely no address or location of your house. And you don't want to give out really information about your family or relatives. Let's do some positives, tell your parents about your Google site. We'll have information for them as well. And we are going to talk about this specifically, so especially if there are any parents with us today, we're not just going to set up the sites as public. We're going to talk about the two options that we want them to do. Either give link access only, so that you can send it to your grandparents, your cousins, your friends, whoever can see it, or make it private so that only people with access to your username and password can see it. Anything on the web can be seen by someone. So even if your Google site is private, someone can see it if they can get access to your username and password, maybe someone on Google, right? Nothing is private. Make sure you notify your parents of anything questionable. Just keep everyone in the loop. And no pictures of yourself on your site without your parents' permission. So if there's a picture of you at lab holding your 3D model and your parents okay it, that can go up on the site. But if it's a picture of you and your friends at lab holding your 3D printed objects, don't get me wrong, I think you should treasure that photo forever. Young engineers of today, friends for life. But that's not going to be something that you want to put up on your Google site because it's a picture of someone else. And just like how you would want them to ask you if they were going to use your photo, you just want to err on the side of caution with that. Better to just put the picture of your object online. And you can, if someone really wants to see that photo, hopefully it's someone you know well enough that you can print it out and show it to them that way. Okay, 7:48. We don't have a lot of time, but we are going to get started on this. HTML stands for Hypertext Markup Language, and it first appeared on the internet in 1991. So still relatively young. Back before the 90s, the internet did exist, but it was unrecognizable. The World Wide Web was not around. And it became the global standard for websites in 2000. So that's really when the internet started to be more recognizable, like something we would see today, when people were using the internet for things like shopping and personal information, chatting, that sort of thing. And every single website uses HTML. That means that we're not going to worry too much about this. We're using HTML5. Every single web page has this file saved somewhere, saved on a server somewhere, has not this exact file, but has a file that's written in this kind of hypertext markup language, where they're using tags, and we're going to learn what a tag is, because we're going to build our own really simple HTML page that you can open on your own computer using a browser. So Every site on the World Wide Web uses HTML somewhere, meaning that it's saved somewhere on a server. What we see is not going to be this HTML, because your browser, whether you're using Internet Explorer, whether you're using Safari, Chrome, or Internet Explorer, wait, I already said Internet Explorer, Safari, Firefox, or Chrome. Your browser is a kind of computer software that takes this HTML document and creates the visual web pages that you interact with. Right? That's you. So HTTP, which you can see up here, or when you're typing anywhere. Whoa. I have a lot of questions. Hold on. This is Mozilla Thimble, portfolio. Yeah, you can send the portfolio to art school or any school. Nothing is safe on the internet. Be careful. I absolutely agree with that. Nothing is safe on the internet. Be careful. And we're not trying to scare you, never use the internet again, but you should be informed about what you're using. I've done it with HTML and created a basic web page. Awesome. Was the text on the sample HTML from that junk Latin site? I don't know. I don't know, Rachel. Internet Explorer. Oh, okay. That's not language I'm going to repeat in this site. But I use Safari and Google Chrome. So I personally am not a fan of Internet Explorer, but to each their own. Was the text on the sample? I'm not sure. We'll see. Okay. Sometimes the questions build up and it takes a minute to go through them. So when you see that HTTP before your web address, that stands for this hypertext transfer protocol. We have the hypertext markup language, where you take the actual content and you put it in these tags that mean different things, and then the transfer protocol. So this is how your computer and wherever you're going, let's say you're in YouTube, this is how your computer and YouTube talk. So the server where all of YouTube's files are. This is a really important thing that I hope we all can walk away knowing. This is not an in-depth class about the internet, but when people, there is a physical side to the internet. There are wires, there are physical servers that hold these web pages. And even when people talk about the cloud, that's just a wireless way to access your files and to save them to a big server as opposed to saving them on your computer. There is still a physical place that those files are being saved. They're not just being saved to air particles up in some cloud somewhere. There's a physical side to the internet, and we're going to take a look at that now, when we build these HTML pages. The servers store the files. It's your browser, which is, again, just a piece of computer software, takes that raw file and makes it something beautiful, nice, and viewable. And that's why some browsers are faster or slower, depending on their coding. So someone before who said that they were not a fan of Internet Explorer. Well, in some cases, Internet Explorer can run slower. Maybe Google Chrome runs faster, depending. And that's why some web pages themselves, if they have a lot of visual content or interaction or videos, are going to take longer to load than others. Okay, it's 7:53. I knew I told you guys that I would. Oh my gosh, there's so many comments. Okay, I know I told you guys that you get a chance to play with those games, so we're going to do that now. This is good because this is about where the other class got to. Let's actually take a look at this, and I can stay a little late with the games if you need help getting if you're going to be a web design professional, you're not gonna be typing your HTML by hand. I just cannot imagine the amount of time it would take, and you'll see when we actually write our HTML pages. It's pretty work intensive. They use software like Adobe Dreamweaver. This is actually a really old picture of Adobe Dreamweaver, I use it in my web design class, and it's really cool and slick and nice. It doesn't look like this old. And this is going to allow you more control, like an easier way. You don't actually have to type all the HTML code by hand. And that's true with your Google site too. The HTML code is still there, but you can drag on an image, let's say, and Google, based on what you drag in and where you drag it in, writes the HTML quote unquote code for you. And I say quote unquote code because HTML is not quite a programming language. And we're going to use the text editor, the free text editor that should already be on your computer, either Notepad or TextEdit. And we're actually going to do the hand typing out. And I see that some people have already done HTML, which is great. It is 8:53. I apologize. I am, truth be told, I am in the central time zone, so it's a little bit earlier for me than it is for you. Okay, so I did put the game codes on Edmodo, and I will copy them onto here now. Whoops. Let's go back from here. So these games are cool because some people said that they've been playing them since they were very little. I will say they do have a young-ish appearance to them, but it's a puzzle. It's a problem-solving. They are problem-solving games, and so oops. Let me put it in the chat. So I think it's still valuable to take a look at and mess around with. This is not homework. This is, hey, do you find this interesting? Do you like solving this puzzle? Do you like looking at these challenges? Well, maybe you should think about, would you like being an engineer? I will say this. I have had a lot of engineers come and talk to my students in high school. I teach high school computer science and engineering, if you missed last week's webinar. And the across the board, engineers talk about, they don't come in and talk about their salary, which is probably good. They talk about how they love to go to work every day because they do something different almost every day. They're problem solving. They're approaching these different problems in new ways. They're not always just sitting at their computer and entering data or doing kind of the same routine day in, day out. They're constantly doing different things, interviewing different people, working on different designs, working in different teams. So just something to think about. I don't want homework. You don't have any homework. No homework. Don't worry about it. Though, honestly, if your homework was to play Tom's Trap-O-Matic, I think that wouldn't be the end of the world. Again, I can't tell if someone was joking, but this is not your homework. These games are what you should do after you are done with your homework. I'm going to have my teacher come out. But it's an educational game, maybe a little bit more educational than Flappy Bird. I would say, if you've heard of a lot of the iPad or smartphone games out there, these are going to be better for your brain than that. Okay, this is an opportunity. Do you have, I love Flappy Bird. I can't play Flappy Bird, that's for sure. If you like Flappy Bird, you should get excited. If we do Scratch this semester, we will have the opportunity to actually code Flappy Bird. And it's not that hard, too, if you think about it. The game itself is pretty simply designed. Press and the bird goes up. Don't press and the bird goes down. Okay, I'm seeing that people are already commenting on Edmodo. I love that. Just make sure that you're practicing safe internet skills. Before it is too hard for me, I agree. If anyone need help right now with Edmodo, getting on Edmodo, make sure that you have filled out this survey. Do you need help with the survey? Look at this. Maybe you don't know how to, let's look. Oh, and Kate, I still need to try your Scratch demo of Timmy. We'll definitely take a look at that tomorrow. Okay, the YouTube site so that you can see all the past ones. Again, if you missed last week, I would definitely take a look at the 7 p.m. Even though I know you all are in the 8 p.m. because I am so sorry about this, but it looks like part of your video got clipped, and I'm not quite sure why that happened, but we went over the same material, so it should be a-okay to watch either one. All right, I'm checking for more questions. For Edmodo, can I share the link to my Scratch project? Gwen, absolutely. Please share the link to your Scratch project in Edmodo. As long as it is appropriate and you would share it with your schoolmates and with me, because I'll definitely be on there playing it. Please do. Edmodo is a place for you to share articles that you might see, like this 3D printed food for soldiers, which is very cool. And I took a look at this. These were the little sugar cubes I was talking about last class. Appetizing. Let's take a look at that 3D printed food. Ooh, they better find a better way to print that. Or if you make your own project and you want to post that. If you want to post a photo to Edmodo, I would definitely keep it just your project.